Hello and welcome to our SOL review of A.02c factoring. Now we've already actually done the main video, but I wanted to reinforce this extra factoring problem, if you will, because this can be a bit more complicated of a polynomial. If you recall from factoring, we're looking to see what can we take out of everything. In this example, 2, -5, and -42, they don't all share a common factor. 5 being prime and 2 being prime doesn't exactly help us. They also do not have an n, all of them. This has an n, this has an n, but not 42. So what do we do in this situation? Well, just we talked about, we're going to go ahead and make our binomials. But it gets a little messy. See, it worked out nice earlier when we had stuff like x squared plus blah blah blah, or a squared. There was no coefficient in front of the squared. Well, unfortunately now we have a 2 in front of our squared term. So, one of our binomials is going to have 2n. And the other one is going to have n. Now the nice part about this is we're still factoring 42, and hang on to your hats because there's a lot of factors of 42. We got 1 and, you guessed it, 42. There's 2 and 21. There's 3 and 14. 4 doesn't work, 5 doesn't work, but 6 does. 6 and 7. Now this is where it gets a little messy. We factored 42, and we need it to multiply to -42. So one of these is positive and one of these is negative. But you have to remember, when we put a number here, this number is going to eventually get multiplied by the 2. See, just by the nature of distributing, I'm not even plugging numbers. I know that I'm going to distribute to here and to there. Just like whatever term is here is going to go to there and also to there. So we've got to think, okay, we know that whatever number I put here is about to get doubled, and whatever number I put here is going to be single. That's important to remember because when we add them up, it needs to be -5. So for instance, no matter how you slice and dice it, 2 times 1 and 42, that's not going to work. It's not going to get us close to -5 when we add and subtract. All of these multiply to 42, so we're not worried about that. We're worried about getting -5. 2 times 2 is 4, and, well, the best we can do there is 25 or 17 by adding or subtracting. So that doesn't work. 2 times 3 is 6. 14 minus 6, that's 8, so that's not close enough either. Let's check here. So we've got 2 times 6, which is 12, and, well, 12 minus 7. Hey, that works. So what we're going to do is we're going to put the 6 here and the 7 there. Now here's the tricky part. Which one's positive and which one's negative? Again, we said it's going to multiply to a negative, so you got to switch them. One's positive, the other one has to be negative. Which way do you do it? Right here is a negative, meaning our bigger number has to be a negative. So 2 times 6 is 12, 7 times 1 is 7. So by virtue, that means we're going to make the 6 negative because when we multiply it, it's going to become negative. So watch what happens when we check our work. 2n times n, that's 2n squared. 2n times -6, that's -12n. Then we're going to do the next term. 7 times n, that's positive 7n. And positive 7 times -6 is -42. And when I clean up those two terms on the inside right there, -12 plus 7, well, then we get 2n squared minus 5n minus 42. So it worked out. We got the original problem. That's a good thing. But wait a minute. Did we answer the question? Which is a factor of 2n squared minus 5n minus 42? Luckily for us, if we just look at the binomials, we'll see that D is our answer. Thanks for watching.